Hi everybody, this is Mr. Mugala with Introduction to Arduino board. In this lesson, I'm going to walk you through the fundamentals of programming in Arduino. As we may all be aware that we are moving from the Mega 32, and then now we're trying to familiarize ourselves with the Arduino board. Now I want to mention that the Arduino that we're going to focus on in this lecture is the Arduino Uno board. But I want to say that the architectural layout of these boards, most of them, they're pretty much like the same. So I thought that I'll just walk you quickly through the board, and then so that we can just walk through. Now I want to show you some features of the Arduino board, and first of all, maybe before we go into that, okay, so here it is. Now as you can see here, that this is a typical Arduino board, and that's how it looks like. I'm meant to capture the Arduino Uno board, but I'm using the Arduino DSML because I couldn't get the board for the Arduino Uno. But then these boards are pretty much the same. So I wanted to show you that even in this example, the major components that are found in the Arduino Uno will be pretty much the same as found in the DSML. But right now, let me just because this is just to help you get the concept of this. We want to make you to understand that on this board, there is what we call the digital pins. All right, these are the input-output pins where you do your digital connections, your digital writings of inputs, where the on and off or discrete values could actually be read from or could be outputted from. So we use these digital pins, right? And you can see on the board as well, we have got the analog input pins. These are pins that we use for processing analog operations, right? So whenever you want to do an ADC, for example, an analog to digital conversion, then you've got these pins that are found right here. We also have the power pins that could output power, but we also have things like the power jack, where once you have deployed this board as a standalone, then you can connect the power jack for it to be operational, because it needs to feed from power. Then we have got the voltage regulator. This has got something to do with the power supply. And we have the USB jack. So this is pretty much a port that you're also using for programming and you connect to the computer using this port, this jack, so that you can download the program into the Arduino. And you have things like the power section jumpers, and these could just be jumpers, all right? The power selection jumpers, where you could select the power. And then we also have this USB chip. Of course, this is a chip that is connected to the USB jack for the purpose of things like compatibility between the computer and the Arduino board. We also have the RX and TX pins. These pins, they are used for whenever you're doing things like the if you're doing things to do with transmission and receiving of certain signals, then TX and RX would be the indicators that help us to visualize whether the Arduino is really receiving some data, or it's not receiving some data, or it's transmitting some data. We also have got pin 13. Now pin 13 is actually connected by default to power, right? And you could actually use pin 13 to have a quick run on your program if you want to test an application, for example, to blink an LED. Then pin 13 is actually connected to the onboard LED, which you can use for testing. So pin 13 can actually be used for testing some sort of application as a response to the programming. And we have, of course, we know that this is an oscillator which is actually connected to the actual microcontroller. So on the board sits a microcontroller, and this is a microcontroller that is sitting in here. You just can't make out what is but mainly they use that mega microcontrollers, and so this is the one that is sitting on the board. So we have also the power LEDs, we've got the reset button, and we have got the ISP header. Now the ISP header, this could be something to do with if you want to program using the ISP interface. You want to program this Arduino board, you want to use some serial way of programming, and then the ISP header is actually really a variable to facilitate all of that. But mainly you can see that we normally use the USB to do the programming. So this is pretty much about the Arduino board, but I want to mention also, why do you need the board? Well, the thing is, before we've actually just looked at the Mega, for example, we looked at that Mega 32 as the microcontroller itself. But you see, these companies, these guys in Italy, they came up with the board to provide you with the basic functionalities that you need to focus on your project, rather than if you bought a chip alone, you start thinking of how you're going to put it on the board, how you're going to load the program into the board. It's really an advantage in the sense that you have the board, and the board provides you with a way to load the program into your microcontroller. It also provides you with other basic functionalities like for testing and things like that, which makes life much easier than if you were to use the microchip alone. Because if you were to use a microchip alone, then you need to do the microcontroller alone, then you need to do your own PCB on where you're going to, how you're going to put it on the board, and then if possible also try to see if you can also deploy it. So deployment becomes it becomes another issue where you have to now think of maybe designing your own power supply to power the chip, and also putting it on a PCB. So all of those things came in to be a bit handy, but one bit complicated. One good thing about the Uniboard is that you just buy the board, or any Arduino board, you just buy the board, and then there are some basic things have been taken care of. Like, you don't have to worry about how you're going to load the program into the chip. That has been taken care of already. How you're going to, for example, putting it on the board, it has already been put on the board, and it provides other functionalities like power as well. Power has already been taken care of. So that's the advantage of getting the board for programming, because it picks you up quickly into you focusing on the actual applications of your problem. Now, if we come to getting started with the Arduino board, so what is it that you need to get started with the Arduino board? So the first thing you need to do is you need to download and install the Arduino development environment. So this is the compiler that we use to program the Arduino board, and so you just need to download and install the Arduino development environment, the IDE, we call it Arduino. Then you need to connect. By the way, you can just download it, just go to Google and search for the Arduino. It's a free software. And then the next thing is you need to connect the Arduino board with a USB cable and install the drivers. So now these drivers are actually inbuilt. So immediately you connect the Arduino board to the computer, it will already start loading the files, the drivers into your computer. Then you need to launch the Arduino application and open the Blink example. Now I'm going to show you in details what this is all about. So what it means is that once you've downloaded I already have mine here. Just a minute. I already have mine here installed on this PC. So if I get if I launch it, okay, so as it is trying to launch, we can go back to the notes, and so you can see here you need to launch the Arduino application and open the Blink example. Now I'll show you that the programs in the Arduino actually are called sketchers, and they are already pre-written basic codes for you to just dive into the application and see how it works. But right now, what is important for you is that you could see here, for example, that once we have launched, sorry, let me just go back. Okay, it's not yet loading, but once we have actually launched it and we can connect and open an example, and then we can select your board and the serial port. So you could actually select the board and the serial port, and I'll show you where all these things are found. But you can upload your first sketch, so that is, and how do we do the uploading and things like that, I'll be able to share. But since in this case we're going to be mainly looking at application with proteus simulation, then I'm gonna show you in details. So for simulation, download the Arduino library. So you need to go and download the Arduino libraries for this, as I alluded to in class, and I'll be able to show you all of this. But later copy the X file and simulating proteus. So if you have a proteus, just like I'll show you an example, I'm gonna show you how we do all of these steps just in a second. Right. Now, when we come to the application itself, it's still loading. Okay, so let's just go quickly into what are some of the most important built-in functions for Arduino programming in C++. Now, we first of all will be programming this board in C++. And some of the most important built-in function for Arduino programming in C++, these as in the eyes of the Arduino, these are some of them. Now you just need to remember this function. Now C++ is not a difficult language to learn, but the way I've packaged all of this, I've packaged it in such a way that you should be able to package it in such a way that you should be able to pick up learning the program itself and also learning how to apply it in the eyes of the Arduino. So what are some of the most important built-in functions for the Arduino programming in C++? For example, here we have a function which has already been pre-built, and it's called the digital write function. And then it takes in parameters. As you can see, there's a round brackets here. So we have you write the function digital write. Notice how there's a small d and there's a capitalized W. And this thing, what it does is it takes in the pin number, and then you need to say digital write pin, then high or low. So what does that mean? This means that you need to write a 1 or 0 to mention pin. Right, so if, for example, here we have a digital write 13 high, this means write a 1 to pin 13, meaning that switch on pin 13, right? And then we've got digital 14, for example, or means write a 0 to pin 14, right? It's simple as all that. And notice how it's exactly reading the way it is. Now we have also what we call the pin mode, pin output. So this, since the pins in Arduino, just like in any other any other boards or any other microcontroller you can be dealing with, you know that these pins can be bidirectional. They can be configured as input pins or output pin. So the output pin. So the pin mode command actually configures a particular pin either as an input pin or as an output pin. So this configure the pin as an output or input. So if we say pin mode 13 output means configure pin 13 as an output pin, and if we say pin mode 14 input means configure pin 14 as an input pin. Right. So we also have another very important function. It's called the delay function. So what the delay function does, it actually delays. This is a very neat function really that has been done in Arduino, and I'll show you another function. It's called the melee function, but later on. These functions, what they do, the delay function, it actually delays the program whenever you want to do applications that do with delays. You could call the delay function to delay for a certain amount of time before another action takes place, and you just need to call delay. So the delay function just starts with delay and then open and close brackets, and then what you put, whatever number that you put inside is a milliseconds. The delay is actually done in milliseconds, and then so the delay function, the value inside the argument is already in what? In milliseconds. So if you say delay 100, it means delay operation for 100 milliseconds, and if you say delay 1000 means delay operation for 100 milliseconds. So we also have a very neat feature here, and I've just put that shows a variable. Now a variable is just a storage space you declare in memory of a computer, and usually a variable is preceded with the word in this case with the data type that variable is going to handle. So in this case, for example, if I start int variable, what that means is that declare a storage space in memory, and that name it the word variable, and let it store the data type integer. So the int at the first here means integer. All right. So but then now we know that these storage spaces could be used for storing values, numbers, and then we can also have different data types that the variable can be preceded with. We can have the float, the string, and I'll show you some other data types that are there. But just know that this comes in very handy. So it means declare string period, and let it store the data type of the integer type. The name of variable in this case is a variable, right? We can also look at continuation. For example, an example, we can say if we write int led pin equals 2, this means declare variable name led pin and assign it number 2, right? And if you write digital read is another kind of a command, which is digital read this pin number. So this is a command to read from a digital pin. Right. So if you write, for example, digital read 12, this means that the status of pin 12 is it high or low. So you're saying the status, you're trying to read from the status of the pin. Remember in assembly language, we had also issues like this where we could use the SBIS command in the Megathek2 board, and then we'd use pin, and then would want to read from a particular pin, right? Now this is another version of the Arduino where we can use, when we want to read from the digital pins, we use the digital read command, and it takes in the name of the pin or the number of the pin. So if I write int status is equal to digital read 12, this means that assign the variable called status, this variable called status, with a digital value. So there could be a digital value either high or low from this pin 12, and then we could assign that value to the status. Here we are assigning the number directly to the led pin, and here we are assigning whatever we are reading from the digital pin, we are taking it to the status variable. So the analog read pin, this is a command to read from an analog pin. Okay, just like we have a digital to read from the digital read pin, and we've got the analog to read from the analog pin. Now we saw that the analog pins are from 0 to 5. Okay, so if we say analog read means the analog value from pin 2. In int ana value, analog read 2 means assign the variable called ana value with the analog value from pin 2. So if we want to get the value from pin 2 and then take it from the analog pin, and then we can take it to that, and then we can work with it. So analog write pin value means write the value to the given pin. So we can write the analog value to the given pin, and then we can use means assign 1 to pin 9, right? Something like that. That is, so of course here we could have 5 right here, because the analog values are from 0 to 5. So that's something that you need to look at, because we don't have digital pin number 9, so analog pin number 9, but we could have, okay, so we do have the digital pin, so we may want to assign maybe to the analog value to the digital pin, and we could do that like this. But I've written here 1. This really here that you see here could be just even an expression to show where this value should come from, right? It could be from a variable or something like that. We're assigning it to a digital pin, so this is pretty much possible. And we'll dive into examples later on. Now here I'm showing you the different data types that we have that we can use with variables. Right, so you can see, for example, here we have the Boolean type, and this is how much space it takes in memory, and this is just for number ranges 0 or 1 or true or false. Okay, so we can, if we were to use a Boolean type, it takes about 1 byte, and then we have got the data type, also a byte, which takes about 1 byte, and this can specify numbers from ranges from 0 to 255. So these are numbers that can get. So we have the character as well. Can see that is this. We have got the unsigned character. We have the int integer, which takes about 2 bytes of space in memory, and that is the range, right? And then we have got all these other different data types that we all know, and this is the number of the ranges that they can take. So now, guys, whenever you be declaring variables, you will see that you will use different data types depending on the convenience of the program. So I used int and variable. So that means that if the number that we wanted was to do with decimal values or something like that, then would say a float variable, or would precede the variable with the float data type. But then that takes about 4 bytes of memory. And now, so the knowledge of knowing how much space in memory each of these data types take gives us an idea how we need to rightfully use the resources or the memory resources. We just can't declare big variables. For example, we can declare big data types for some variable if the application really demands more storage space. Every time you do it, you are consuming some spaces in memory, so you want to be prudent on the use of the memory spaces. So the different data types would be convenient for different applications that we'll be looking at, and sometimes we may not use the int, sometimes we may just use the byte, for example, right? It takes about 1 byte. This one takes about 2 bytes. So depending, sometimes we may use the unsigned long, unsigned integer. Sometimes we can use the unsigned long based on how much storage, and this takes about 4 bytes. So this knowledge is helpful in trying to prudently use our resources, memory resources. Let's come to writing a program in Arduino and introducing the C++ concept. So here's a simple question. So the question says, write a program in C++ for the Arduino board that blinks an LED connected to port 10 every 1 second. Right? So how do we do that? Okay, so I'm just going to go through this, and then I will try to write that program for you so that you can see how it works and how simulate it with proteus. So the first thing that we need to do is you need to see, guys, that we could actually declare our variables. So if I declare this variable outside any of these functions here, like the void setter function, then it has got a global perspective. And I'll talk about the global perspective later on, and the global scope and the native scope. I'll talk about them now, but right now what you just need to appreciate is that what we've done, we want to program pin 10 as the local, we want to program pin 10 to be the one that is going to output, right? So the LED is connected to pin 10. But right now, what we've done, the first thing we've done is that we've declared our variable. We declared our variable to be a late pin is equal to 10. So what that means is that the pin number, which is pin number 10, the digital pin 10, is going to be assigned to a variable called late pin, right? And every statement, whenever you write in C++, it has to end with a semicolon, and this is exactly what we've done. Now, when I come to the void setup, the void setup function is a very, very important function. Actually, in Arduino, there are two major functions that defaults, right? So the Arduino sketch or the Arduino IDE, whenever you try to run a program, it will default to two major functions. That is the void setup function and the void loop function. But it's very much important to see that the void setup function has got its own opening curly brackets and the close curly bracket, and whatever instructions we need to put them between these open and close. And the void loop also have to put between the open and close. But what are they? Right now, think of, first of all, this is a function. How do I know it's a function? Well, the word setup, open round brackets and close round brackets, it shows me there's some sort of a function. But the word void, in this case, the word void means this is empty. It means empty. Whenever you use the word void in this case, it will mean empty. So this is a function called setup, and it's an empty function because it's not returning any variables within these curly brackets, right? But then it has got statements that it can work with. And then now what it means, the void setup function is a function that comes with on the Arduino, and what it does is that it puts up the basic setup of things. Now, what is that basic setup of things? Well, this is where you put things that will run only once in the program, the setup things, like port configurations, for example. What are the status of port? This is like the initialization section where you initialize parameters that will only run once. Now the void loop function, this is also void, so it's an empty function, but then it has got statements under the curly brackets that it runs. And the function of this is that it loops. This is where you loop through your program. So the boundaries for looping are between the open curly brackets and the closed curly brackets. This is the block of code that will loop. So the way to work it will run this statement, run this statement, run that statement, and when it reaches the end, it goes back again to loop through. This is where, like in assembly language, we said main rjmp main. Right? This is where the main looping takes place, and it loops forever in this loop. Right, so now you can see here, to write this program that switches on an LED, what we've done is that we're saying that LED pin is equal to turn, right? And then we're saying that in here we're trying to set up what is this pin supposed to be. Is it going to be an output pin or is it going to be an input pin? So we're saying that we use the pin mode command, which I just showed you, the pin mode, right? So we're saying that this digital pin, which we've now called late pin. So whenever we do things like this, we say once we assign that pin is no longer called 10, but it's called late pin. So we're saying pin mode late pin output. So we've configured pin 10 as an output by virtue of doing this. And then we can see here as well that we can now, in the loop function, what we do is we use the digital write. We can use the digital write late pin hide, so we switch on the late pin, which is number 10, and then we delay for 1 second. It's a delay function. We call the delay function, which is 1000 milliseconds, which is 1 second. And then we delay for 1 second, and then we write the pin again low, and then we delay for 1 second, and then we loop back. So let's just go through it real quickly. So what we're saying is that we switch on the late pin, pin 10, it's high, and then we delay for 1 second. Again we switch on, we switch off the lead pin, and then we delay 1 second before it loops. So the statement would be like this: delay, then switch off, then delay before you come back to the digital lead pin. So that's how this functionality of this program, actually that's how it works. Right now, guys, all of this down is an explanation of what this is all about, and I'll show you. You have my document, you can get to read what this is all about. This is what is known as a variable, an integer range, and I'm explaining exactly what we're going to do. But right now, what I want you to do, you can see here the void. So we have this. So you have set up an area memory to store number of time integer and store in that area, just like I explained. Next, we have a setup function. It's a void setup function, pin mode lead pin. An Arduino sketch must have a setup function and a loop function, otherwise it will not work. Okay, the setup function is run once and only once at the start of the program, and is where you will discuss this general instruction to prepare the program before the main loops run, such as setting up the pin mode, setting up serial baud rates, and etc. We also have our setup function only as a statement in this case, and that is pin mode. Here we're telling the Arduino that we want to set up the mode of one of our digital pins to be output mode rather than input. So within the parentheses we put the pin, and that's what we do. Our pin number is lead pin, which has been previously set to the value of 10 in our program. So therefore, this is a statement is telling the Arduino that the digital pin 10 is to be set up. Then we have the void setup. Here we're telling our compiler that our function is set up, returns no data, void, and that we pass no parameters, empty parentheses. If our function was of an integer type and it would run integer values, it would look as this. Okay. So, but then now real quickly, let me just dive into the Arduino and the Proteus to just show you how this program would actually work. So the first thing that we want to do, so this is the Arduino IDE I talked about. So what you just want to do first of all is that you need to go to File and say New, right? Alright, so if you open the new program, you can see here that there's the void setup function and there's the void loop function. So what do we do here? Again, so we can see here that we can write our program. We can say int lead pin, we said it is equal to what? To 10, and then we can end that with a semicolon. Here in the void setup, this is where we put the pin mode. So we can say pin mode, pin, output. We have configured our port as an output port. What we do, we can now from here we come to the loop, right? This is where we have to loop in our program. So we say digital. Right, lead pin, comma what, comma high. We switch on the LED by this function, and then we delay for 1 second. And then we switch off. We say low, and then we delay again for 1 second. Okay, so you can see here that the code has been completely written. Missos, come and get please. You'll not my video be disturbed. So you can see here that we've actually written the code, and the way we actually compile, we just need to go to Sketch, Verify and Compile. If there's no any mistake, you can watch down here. So okay, so first it has to be saved. Second, delay. I call this as 1 second delay, and this in 1 second delay. Okay, so now it has been, so now it's compiling. So we have to wait till the program compiles. Yeah, it's taking a bit of some time, right? Okay, so while the program is compiling, I'd like to really quickly set up this same thing, and we'll come back to the program after just compiling. It can maybe be done anytime soon. It's quite slow, right? Okay, I wanted to show you quickly. We can now start setting up. While the program is compiling, we can really quickly try to go to proteus and try to set up the we can try to set up at the same time we can set up the Arduino. So if you have your libraries set, you can come and search Arduino. So we're using Arduino Uno R3. You can get it to the board, right? What are we dealing with? We're dealing with pin 10, pin number 10, right? Alright, okay, so pin number 10 is this one. So what you're going to do now is that you're going to try to pick the device. Let's see, pick an LED. LED, so I'll take it from, come on, the computer is freezing. Pick it from the optoelectronics, then we can come to yellow and paste it there. Alright, so you can place the ground, look for the ground, terminal, ground. Right, so you can see here that we can connect. Come on. This is everything. Computer is freezing. Okay, so we wire that. And then we can come to pin number 10, which is right here, the one we just programmed, right? Okay, so now we've set up our circuit in Arduino. In Proteus, and then we can come back to check if our code has compiled. It's crazy, it's taking almost forever. Why? Let's close this. Just to compile a simple program. So I'm working now. So as I'm doing, I'm trying to, just a minute. So I'm gonna exit this and let's go. Taking so much time to compile a simple problem, right? These things need to be gone. Okay, so now we can see. Still trying to compile a sketch. Come on, man. Okay, so basically what it is, if we come back to Proteus, for example, then you will actually need the same way we've done with at Mega 32. Then you can come to this, and then you can search for where your hex file is. Now I have my X file, hex files actually kept in a folder. I have to go to the documents. My hex files are actually kept in the folder called Arduino. Come on, man. This thing is delaying. Okay, so let me just go into delay, man. Well, if so, this is where my hex file is, but just want to come back and see if this guy is. There's something going why is it taking so much time? Okay, it's actually done compiling. So what this means is that we've done compiling, and you can see here whenever you see the just white words right here, it actually simply means that we're done. So if there were any errors generated in this program, for example, if let's say I forgot to put, okay, but first of all, let's say if I forgot to put the semicolon there, for example, right, and I'll say verify and compile, then definitely to just generate an error. You can see there's possible errors that could be generated as a result of maybe forgetting some. Come on, it shouldn't take this long. Right? So you can see here that it's saying that there is an expected semicolon somewhere before it is just a token, right? So before that there's an expected, so there's an error here. So you need to know that every statement has to end with a semicolon. So if we just now verify and compile, that's one of those errors to generate. That's one of the errors to generate. So now we can verify and compile again. I've put it back. I've put it back. And so now we are compiling. And then we verify now. And compiling is done without those generated errors. Now the first thing that you want to ask yourself the question is, where do we get the hex file? Right, so now in order to get the hex file, then you need to go into Sketch, show the sketch folder. So you go to Sketch, then it says show sketch folder. You wait for the sketch folder. And then now you can see that the 1 second delay only has got one file, but we don't see any hex file in here, right? So there's no hex file. So sometimes you may not get it all at once, But all you need to do is that you go back to Sketch, and then you need to export compound binary, right, which is Ctrl-Alt-S. So if you say export compound binary, let's just export compound binary. If you don't get the X file, then you need to export the compound binary. So we wait for the exported compound binary. Alright, so now it means it has done comparing. It has actually exported the compound binary, so we can go to the show sketch folder, and once we go to the sketch folder, we should be able to now, we should get the hex file. So that is your hex file right here, right? Now, because so if you want, you can copy the hex file wherever you want, but I've connected my folder directly to this so that I don't move around. So what I need to do is just to simply go back to proteus and pick that hex file, and the hex file here is actually found in the it's actually found in this. So we go to my documents. So where is it now? So I can check in the documents. For me, it's here, and I can pick it right here where the Arduino is. And my 1 second delay is here, the one we just wrote, and this is the hex file. Alright, so that's the hex file. You get the standard hex file. You can see here there's the what bootloader. That's not the one that you need. You just need to pick the standard hex file. Then you open it, and that's it. It means it's done. Okay, so now you can run. No problem. And let's see if the LED will be blinking every after. Let's see if the LED will start blinking every after 1 second. You can see here that it's blinking. We're going. Blinking, it's blinking every after. You can see here that it's blinking every after 1 second. Alright, now thanks a lot, guys, and you're gonna have to try this yourselves and then see how your applications are going to work. Okay, and I'd like to thank you for viewing for this introduction, and then later on we're going to have more examples that I'll show you on how these things work. Thank you.